So we are starting, guys, graphing and evaluating piecewise functions. So let me kind of define this really quickly before we even go any further. The following graph is called a piecewise function. So this is what's called a piecewise function right here. Right? Because the function, which is by the way one function, even though you have multiple pieces, this function is defined by two or more different sub-functions, which is called pieces, okay? And each sub-function, which is now called APs, make up the main function's domain. So question number one, how many pieces, Sydney, did you see on here? 3, you're right, there are 3 pieces. 3 pieces make up how many function in here? 3 pieces, but how many function, guys? 3 pieces, how many function? One piecewise function, okay? Again, 3 pieces, but 1 function. That's the difference. It's still just a function, but it's called piecewise because it's made up of multiple pieces. Now, are they segments or array, and how many? Daniel, do you remember what a segment was in geometry?
Where it's a line but has 2 endpoints.
Yeah, so how many segments do you see in here? 2, you're right, 2 segments, okay? And how many rays? Emma?
1 ray.
1 ray. So class, what's the difference between a line and a ray? We've been graphing lines.
A ray goes on forever, or like for its point, and has 1 endpoint, but a segment has 2.
Right, a ray has 1 arrow, a line has 2, yep. Okay, so a line goes on both ways, both sides, a ray goes on one side. So, definition of a function. Can you please help me read the definition? Carly, can you help me read the definition of function?
A function is a relation from a set of inputs to a set of outputs where each input is related to exactly one output. You can also check by using a vertical line test.
Perfect. Okay, so here's a vertical line test. That means you're drawing a straight up and down line. Here's a piecewise function. Is this a function, class? If I draw a line, okay, is my vertical line going to intersect at any time 2 or more points? I see this and I see this. So if you said yes, what are you thinking about? Are you thinking about this?
Yeah.
Look at this. This vertical line intersects this and that. But anybody tell me, what does this even mean? This open circle. What does it mean in mathematics? Open circle.
If it's an open dot, then it would pass the vertical line test as long as it's not 2 open dots. Like one has to be solid because it's not at that point. It's just a placeholder.
Yeah, good job. It's a placeholder is right. An open dot, meaning that it's not even there. Okay, it doesn't even exist. Okay? Like she said, it's close to it, but it's not. It does not exist at that location. A closed dot meaning, does it exist? Yes. Okay, you do have a value here. So even though this vertical line test runs over 2 dots technically, but one of the dots does not even exist. Okay. So is this a function? Yes or no? Remember, yep, it passes. Right? When we say it passes, that means it does not intersect 2 points at any given line. Now, one-to-one function. Okay, Kai, read one-to-one function, please.
Is a function where each input has exactly 1 output. You can check this by using a horizontal line.
Right. It's again one-to-one function. We're going to see if it's a one-to-one function. Each input has exactly 1 output, and each output has exactly 1 input. So I'm going to draw a horizontal line test. Let me just go from left to right. Is there a horizontal line that intersects at least 2 points?
Yeah.
2 or more points? Yeah. This one intersects twice. Isn't this line right here intersecting infinitely many?
Yeah.
So is this a one-to-one function?
Yeah.
Did it pass? It did not pass. So is this a one-to-one function? No. It's a function, but it's not a one-to-one. Okay. A one-to-one function is 1 input can only have 1 output, vice versa. 1 output can only have 1 input. Can you see that this y value right here has multiple input, isn't it? That's not okay. Then last one, continuous. Braden, can you read me continuous, please?
Yes. So when you carry a graph, you can graph the function without lifting up your pencil.
Right, right. So, is this a continuous piece? No, because I have to lift up my pencil to go from one piece to the next. By the way, not all piecewise will be discontinuous, okay? Some of them will be continuous. All right, definition number 2. The first definition are kind of guidelines of how to find x, okay? How to find y if x is given. Then the second one are guidelines, and we'll read it together. How to find x, okay, if y is given. So copy that down, and we'll come back together to read it. Right, so if I were to like voice, be quiet, copy, just be quiet. Again, if you cannot print at home for any reason, please come and see me. And we are taking this section very slowly, just because it's really confusing, and I want you to understand it really well. This one will not be on your quiz on Friday. Very good question. Just the first 2 set of notes. This one will be on the next quiz. Because I want you to practice it a few times before. By the way, do you know tomorrow's minimum day? Yay. That means if you have a 0, you don't start until 7:45. If you don't have a 5th and 6th, guess what time you get up? There you go. I want to read as you guys are finishing the writing. Evaluating piecewise function given x. That means you're really looking for y. So to look for y given x, there are 2 ways. Okay? I could give you a graph, or I could give you an equation. Let's start with using the graph. Chance, can you have read number 1, please, on using the graph?
Find the x value on the graph.
Perfect. Okay, look at the graph. Where is x located? Number 2, James, can you read number 2, please, on using the graph?
See what y value is defined at that x value.
No, I think we're going to take a nap. We want to do the same, don't we? Yeah. All right. And so once you've located the x, see what y value is defined at that x location. Now, what if I give you an equation or a function? Hunter, can you read number 1, please?
Determine which equation to use by looking at the domains of each piece.
Good. I'm going to talk to you guys about that in a little bit. So find the domain to see if it matches up to the x. Number 2, can you help me number 2, please, Gemma?
Number 2.
And using the equation to find y if x is given.
See what x value is defined at the y value.
Using the equation.
Oh, that one, I don't know if it works. Substitute given x value into correct equation.
Good, okay. Then, Hope, can you read 3, please?
Evaluate.
Yeah. Guys, evaluate is another word for what? Solve. Find the answer. Okay. So that's if we're looking for y, if x is given. I can also ask you to find find x and give you y value. So, Joseph, can you help me read number 1, please?
Find the y value on the graph.
Perfect. Number 2, Madison R., can you read number 2, please?
See what x values is defined at the y value.
Sometimes there's more than one. Okay. 3, Brandon C., help read 3, please.
Which one?
The one that everyone's reading, my dear. Given y, look for x. I'm highlighting blue. Find find x given y. You're reading 3.
If you can't see it, determine which equations to use based on the graph.
Thank you, sir. And again, we're going to go in detail with this. Okay, Zoe R., can you read 4, please? Very good. And last one, Aaron, can you help me read the last one?
Solve for x.
Perfect. Okay. So all of that is a lot to take in, but we're going to do one at a time. So that way you can understand what I'm talking about. Some of you are still writing, so I'm going to leave it up. I think most of you are on this one, so I'll just make that bigger. I'm done grading your tests. Hopefully I'll enter that in today or tomorrow. Grades are due tomorrow, so no later tomorrow, that's for sure. And then hopefully you get it back on Friday. Okay. I thought you guys did amazing.
What was the lowest score?
I don't remember. I have 111 students. I cannot remember. I don't remember. I don't remember one specific person, but overall, I thought you guys did really well.
What was the average?
I don't know. I haven't entered anything in. The rule of thumb is, if you take your homework seriously, would you do well? Yeah, I guess. Okay. If you copy homework, would you do well? Probably not, because you probably don't know what's going on. Okay. So, I don't know. I haven't entered anything yet. So let me enter stuff in, and then I will make a clear announcement of when retakes are. You guys know about the retakes? How high can you get up to? Not 85, but 80. But you do have to do your homework. Your homework packet's got to be all there. Do ever teachers give the same identical test?
Yeah.
My physics teacher.
My math teacher last year. It says 85.
I would refer to the syllabus. What does it say on there?
The maximum score you can turn on a retake is
85 it is. Thank you. I don't remember. Every class is different for me. So 85, that's even better for you. But there are contingencies, right? What are the contingencies?
In order to be eligible for a retake, you must finish tutorial, do test corrections, and complete a certain percentage of assignments.
Thank you. Okay. So 85, guys, you can't miss that. You can't let that opportunity go by. Okay. All right. Let's do example 1. I'm going to, again, example 1. Yeah, it's impossible to fail this class. I like the way you said that. Okay. All right. Direction, graph the piecewise and answer the following questions. Question number 1. Gabriel, how many pieces is this piecewise? Very close. Very close. No. There are actually 3. Okay, let me teach you how to read a piecewise. Hey, many of you, this is your first time seeing a piecewise function, so it is not something that you can joke about. This is one function. Can you see there's only one f of x? One function equals to 1 piece. This is piece number 1. What's this inequality over here doing? X is less than -2. X less, what does this tell you? I can only use what for this piece? -3, -4, -5. Can you see how this is read? F of x equals big bracket 2x plus 1. If and only if x must be less than -2. I can use -2.5, couldn't I? Because is -2.5 less than -2? Sure. But can I use 3 for the first piece? Can I use 0 for the first piece? No. So that's how we read that. Piece number 2, -1/2 x plus 6. I can only use what values of x for the second piece? From -2 all the way to? That means, can I use 7 for the second piece? No. Third piece, it's just simply at 3. That means y is at 3 when x is greater than 6. So what happens to the third piece when x is at 10? Y is 3. What happened when x is positive 100? Y is still 3. So we're going to do one piece at a time because this is your first time, many of you, first time introducing piecewise. Piece number 1, that's what I'm going to write. I'm going to write it all out. Piece 1. I'm going to make a chart, a table. Okay. And we have to understand how to read it. If you don't know how to read it, then we can't apply it to our graphing. Piece 1 has a restriction. X has to be less than -2. So what that means is I can use -3, -4, -5. I can also use -2.5. I can also use -2.1, couldn't I? So I can use as close to -2 as possible, which is never, never, ever use -2. Okay? So at -2, technically you would have a what? An open circle. So I'm going to start with -2, knowing that I will have an open circle. Okay? Again, I'm going to stop right there. I'm going to pick -2, knowing that it will have an open circle. Then I'll pick a few more values, usually 3 total. What else can I pick in my input for the first piece? Negative what? 3. And then one more. Perfect. Let's plot it in. First piece says 2 times -2 plus 1. What's the output for that first input? Negative what? I'm sorry, I put in -1. There's -3. Thank you. -3. Now I'm going to also spell out this is going to be an open what? Open circle when I plot it. Okay? That's the only one that's going to be an open circle. Okay? Now I'm going to ask you, Lena, why would that first dot be an open circle? Lena? So, because this location of input, can I use it technically? No, but I'm starting there because remember, your x value can get as close to it as it can be over okay? So that's what we're using it, but it does not exist. Okay, x cannot exist at -2 for that piece. Then let's plug in -3. So 2 times -3 plus 1. Brandon N, give me the output, please. Thank you, sir. And last one, 2 times -4 plus 1. Give me the output, please, Anthony. Thank you, sir. I'm going to plot those 3 dots. Here we go. -2, I'm going to go down at -3, open dot, like we said. -3, go down to -5. 1, 2, 3, 3, 4, 5. So here we go. -4 is now -7. I have 3 dots. I can make a nice straight line. Do I make a straight line going both sides, both left and right? No, it's just going to be a ray going one way. Because technically, can I have -100? Yeah. Okay, so I have a ray going one way. That's piece number 1. Piece number 2, it's in the middle. That's what I'm going to use next. Okay. Look at the restriction for piece 2. What's the smallest value I can use for piece 2? -2. Would that be an open circle or closed? Closed, because it's inclusive. See this equal? What's the largest input I can use of these two? 6. That's my first and second, and then I'll pick one in the middle as well. So that's X, that's Y. I'm going to use -2 and 6. Dylan H, actually he's not here. Madeline L, can you give me one more value in between? 3. Very good. Let's plug it in. Here we go. -1/2 times -2 plus 6. Okay. Give me, please, the output. Jack, in your team, talk it out. Give me the output for -2, please. Thank you, sir. And let's do -1/2 times 3 plus 6. Victoria, work with your team. Give me the output, please. Oh, this is 2 right here. So all Victoria's team, work together. Give me the output. 7.5. Do you guys agree? What's -1/2 times 3? Negative what? -1.5 plus 6 is now a positive what? Thank you. Okay. So one more. -1/2 times 6 plus 6 equals. Grace and team, can you guys talk it out? Work together. Okay. What's the output? 3? Yes, no? Yeah, let's plot the dots. So I will start at -2, go up 7. So -2, 2, 4, 6, 7. And remember, we said none of these should be an open dot because they're all inclusive. +3, 1, 2, 3, go up 4.5. Then +6, 2, 4, 6, go up 3. Okay. Do I make a line through those 3 points? Or just a segment? Do we make a line or a segment? Just a segment, okay? Remember, the second piece does not allow for X to go on forever. It just said from here to there. How many more pieces do we have left? 1, piece 3. Okay, I'm going to start with X and Y. What is the smallest X we should use? I'm going to use 6, but at 6 you will have what kind of circle? Open circle, okay? Well, I'm going to use a couple more. Wait, what happened to the output? We'll plot it tomorrow. At 6, Y is? At 7, Y is? At 8, Y is? All right, to be continued.